time, we discussed the telescopes we got here. And I'll be setting up outside. We get a good look at the sun. You can see, hopefully we'll see some solar flares and some sunspots. I'm going to turn the program over to Floyd, who's going to start with our star.
Hello. How y'all doing? I thought we'd start out at the center of things. Consider Earth the center of things, but actually the sun is the center of our solar system. So what I want to do is give you a little perspective on how big things are, and how small things are. So, did you want to help? Okay, come on.
I also wanted
Need some more volunteers.
I also wanted to tell you that I did a science project on this.
Did you?
Oh,
Yeah,
cool.
it's about how big is the sun to the
Okay.
Earth, and mine was the biggest project.
Oh, that's
I
good.
read out the paper.
Okay, now, we're just gonna add to your project a little bit, okay? Now, you see a solar system up here. That's the sun, right? But you see how big the planets are? Look how big the planets are. They're not really that big. See Earth? And how big it is to the sun? Let me show you something here. If I can get that stuff. Ah, here they are. I've got a little plastic container full of Earths. And who would like to come up and distribute these among everybody? Okay. Well, come on up then. We can't say no. We gotta say yes, okay? Now,
So big.
now these folks over here, these grown-ups, they're gonna participate too, okay? So they're gonna be part of this. So that's why I want them to pay attention, because I'm gonna show you some things, and I'm gonna teach you some things, and they've got to participate, they've got to help you, okay? So, all right, let me give you a couple of these. Don't lose your ticket. We start distributing those among the adults. Okay, you do the same thing. Okay, you all can keep these. Okay, there we go. Those are things up. Okay, who else? Okay, we give those to the rest of those kids.
You got two over here.
Give them each one.
Hey, Lloyd, behind you there. Those two right there.
Right here.
And then two more behind them.
Anybody that needs some more, you give him one, and you give her one, you give her one, okay? We got bunches of them out.
You got two back here.
Okay, you give them one, you give them one, and one. Now, does everybody have one? All the adults, this adult here, you have one? Do you have, no, not the ticket, the Earth.
No, no.
Yeah, run over and get them one.
He just has.
You just have, who has more than one? Yeah, who has more than one? Okay, give this gentleman back here one. Any other adults that don't have one? Down there? Okay, everybody move back to your sitting space. Now, what's the closest star to Earth? What's the closest star to Earth? Anybody know?
The sun.
Exactly. She was just getting ready to say that too. The sun. Take this. That's the Earth you have in your hands, okay? Roughly 8,000 miles in diameter. This is 860,000 miles in diameter. Picture yourself, just in this community here. It's a pretty big compared to you, right? Just this area, say an acre. You're pretty small in that. Imagine the state of Tennessee and where we are now and how big we are. Imagine the whole country. It's a lot bigger than the state of Tennessee. Imagine the world, how big it is compared to the country, USA. Now, that's going to be on that little ball, little bead you got in your hand. This is the sun. Let's start walking around and stick that little ball right up next to that. Okay?
Sun's going back.
Another poster of the Federated Sun. That's okay. I got it. Okay, while she's doing that and you're making that comparison, let's talk about the sun a little bit. You see, this is a kind of a perspective on the sun, what the planets are. Earth is going to be about this size right here. And you've got the Earth in your hand, and you've got the sun right there. Now go around to the adults too. Make sure all of them get that. What about you all? Do you all have an Earth? You two? You three? Who has more than one? Go back and give them one.
I have one.
That's okay. You're busy.
You're the sun.
You're the sun. She wants to do it all. Okay. It's about 5 million tons of matter being converted to energy in the core of the sun every second. Okay? 5 million tons. And its process that does this is fusion. The sun is a very large object, but it's not very large compared to other stars. So we're kind of a medium to small star, which is good. It's good for Earth. So we get a lot more hydrogen to helium burned. You got it? Now you can set that down right there, and I'm gonna be showing some other things. So you can go ahead and set it if you like. But that allows us about 10 billion years. We're about halfway through that burn right now. And it allows us the stability to form life on Earth. Okay. Earth's about 4.5 billion years old. Now, how did all this get here? How was it all started? Well, let me show you something. See this right here? He knows what that is. Your kids will be seeing this in your science classes. It's a periodic table. It's got all your elements in it. How do they get here? How does all these elements get here? How? Yes, but how did God get them here? God spoke the word.
Magic.
He spoke. No, God's much more technical than magic. God works very hard. So what I want to do, I want to pass this around. Have any of you been out on a night sky and see the streaks come over, see meteors, falling stars come over?
No.
Well, those are meteors.
I see two.
Those are meteors,
I
okay?
saw two.
And this is, when they hit the earth, they're called meteorites. That's what this is, okay? It fell in Siberia. I bought it in California, astronomy event, so I didn't find it. I'm gonna pass this around. I'll pass it to the kids first, and then you hand it up to the adults, and the last one, please hand it back to me if you will, okay? But that's iron right there, iron and nickel. You'll see that right on about midway on the chart here. How did all this get here? Well, let's look back. That's the Veil Nebula.
That's what?
The Veil Nebula. It's a remnant of a supernova. Star blew up, a big star. That's how all these elements got here, through supernovas and hyper supernovas. Okay, that's how they got here. The furnace, the nuclear furnace, extreme heat, extreme pressure. These large stars. The hemoglobin, the iron in the hemoglobin in your blood, came from the star. From the star. That's what absorbs the oxygen in your lungs, passes it through to the cells and keeps you alive. And plus all the other elements that are in the food. Just want to point that out. So what does it take to make a solar system? This is a Trifid Nebula, right? If you're looking up towards Sagittarius, you can see this. Through binoculars or through a telescope. You can see this. It's a huge cloud of gas and dust. It's a star-forming region, okay? Stars being born in here, like the sun, okay? What does it take to make a star? A whole lot of gas and dust in an area like this. Gravity. You get a shock wave go through from another exploding star, it starts things in motion. The next thing you've got, they call it an accretion disk. That's why our whole galaxy is laid out in a disk. That's why our solar system is laid out in a disk. It all accretes. It starts out gas and dust and starts lumping up. Gravity, as it gets bigger, gravity pulls it in, and mostly to the center, because over 99% of the matter in the solar system is right here. The rest of it's in planets, asteroids, it's out in the Kuiper Belt, with untold billions or trillions of objects there, and then on out to the Oort cloud, where a lot of your comets are. So that's kind of how things get together, all right? Now, let's look at something we call an eclipse. I'll need some help. Need some help. Okay, just you're good. You, since you're convenient. Now I need the sun goddess. Where'd she go? She's the one that did the project, so I'll give her extra credit now. Just go ahead and pick up the sun. You got the moon. Okay. Now, you stand over here. We've got the sunlight coming from here, and then now you want to face them. You face them too. You got the moon over here, you got the shadow off the earth onto the moon. What kind of eclipse is that?
Solar eclipse.
Lunar. Because you're looking at the moon and you're looking at their shadow. Okay. You got pretty close. Okay. Now you come over here in straight places. You stand right there and face that way. Now we've got the moon's shadow on the earth, and you're looking at the sun being blocked out. I bet you know what that is, don't you?
Solar eclipse.
There you go. Indeed, that's a position of it. Okay? All right, now, let's see. You go ahead and just lay that down. And, no, you can pick that back up. And you're good here. Now hold that up. Okay, let me get positioning here. All right. The Earth's axial tilt is 23.5 degrees, okay? You see it here, how it's tilted? Okay, what season? What season is this? Can anybody tell me? It's summer in the southern hemisphere. It's winter in the northern hemisphere because we're angled away from the sun, okay? So what this does, this gives us shorter daylight periods, okay? And it also takes the heat, the radiant heat from the sun, and spreads it out over larger areas. So it's not as concentrated, all right? But it is concentrated more in the south. So it's summer there and winter up here. Now, you walk right around there and you walk right over here. Okay, on the other side, you walk right over here. Now, tilt that forward there. That's what it looks like. She started rotating there. Now this will be summer in the northern hemisphere because the axial tilt is leaning this way, okay? That's what causes your seasons. Then everything else is just a variance of winter and summer, okay? Spring and fall, okay? Now, another thing too, is you're looking out into the cosmos, right? You see all these stars. Different times of year, you see different stars, right? Why is that? Because we're right here. Now, nighttime is going to be in the shaded part of the earth. We're looking out this way, okay? Now, we're going to orbit right over here. We're standing right over there. And when we're looking out here, we see a different set of stars. Over there. Looking out that way, you see even a different set of stars. And the same thing from here. So you're looking at all these different stars in different seasons. That's why they all change. Okay. Go over here. I'll get this back in a minute. And you put the sun down right there. Now, what I'd like to do, parents need to help with this. I'm going to teach you how to use a star wheel. Okay? Now, I want the kids to go stand next to their parent or the adult that talks or their name. Thank goodness for names, huh? Okay. I want to hand these out. You may have to share. If I'm on the couch here, share. You can sit there. Share. All right, here you go. You guys share. And if you don't have a pen,
You're right.
Okay, can we do that?
That's not okay.
Listen, at the end, you imagine this being the style of the
Okay. Who else needs one? Over here? You got one here? Can you share here?
Can you see?
Okay, I'll share here. All right. Okay, look up. You have to find someone to share with us. Everybody have this
That's one
kind of
thing. Walk
teaching.
behind.
You got one back there? We're going to have a, remember, we're going to have a test. We got one up there. Find somebody, stand at the back of these folks here. You can. These are just, how about 2 or 3 of you coming over to this gentleman? Okay. Everybody got one? Okay. Okay, now listen up. I'm going to teach you how to use this. Hey, adult. Kids will pay attention. And I know it's good to get ahead. That means you're curious. All right. All this is a calendar and a clock. Okay? Calendar's on the outside. You see the months of the year and the days of the months. On the outside, it's real. Okay? This disc right here. The clock is right here on the inside. This. Okay? That's where it is. So all you do, what's today's date? What's today's date? Anybody know? Nobody knows what today's date is? It's what?
22nd.
It's the 22nd. I have one person in the room knew what it was. All right, July 22nd. Say we're going to observe at 9 p.m. tonight. Back row, listen. 9 p.m. tonight. Okay, you place your time that you're going to observe on the day that you're going to observe. Okay? Everybody got that? Okay. And that's PM, 9 p.m. Okay, it's 9 p.m. Everybody know that? 9 p.m. On July 22nd. Now, see what that looks like.
Here's the idea, not here.
Is that what we put?
That's what I did, yeah, it was like, just barely moved just a minute ago, so it's.
You know that the 22nd is between the 23rd and 21st, don't you? I have people ask that question. Well, it's not on
Well, it's
here.
fine.
I said, you got to read between the lines. Okay, so,
Question, we have a question.
yes, ma'am.
There's no stupid question, is there?
No,
Okay.
just stupid
Does this
answers.
ne- No, not so does this need to be here or the 11 here?
No. No, it's 9 p.m. on the
Okay.
22nd.
Okay, so that's what we had 11.
Now, everybody's star wheel, pay attention, everybody's star wheel should look like this. Because we're going to be looking north instead of south. Okay? It says face north. Should be face, you see face south is upside down, that's not the way you normally read that. So we're going to be facing north the way you normally read it. Okay? And we're going to say, okay, let's just say that this way is north, okay, for convenience. We will do, we'll have to orient ourselves to the north. Now, the reason we do that, I need, let's see. Can you help me? Let's hold it right there. Now, you see this brad? This is what holds it together, and this is what it all rotates around. Now, you see anything else that rotates? The earth rotates, doesn't it? 24 hours, it's 1 day, right? One rotates. This is 24 hours. It corresponds with the rotation of the earth. You see the earth's axis here? It points straight to this that rotates, right? It's the North Star. It's Polaris. So that's how that works. Isn't that simple? Just as simple as it can be. So that's why the stars are rotating overhead. Now, does anyone see planets, asteroids, comets, or the sun on here? You don't see that, do you? The reason is because they're constantly moving. They're close. They're constant. Now the stars, they don't move that much. If I can find it. Ah, here. I'll show you. This is your Milky Way. And your Milky Way is right here. That's a galaxy that you live in, okay? And you'll see an edge on right here. That's it. See the blue area? It looks like a river. That's the edge of your Milky Way. You'll be able, in a real dark sky, you'll be able to see about 6,000 stars if you got good eyes. Most of them. And so we're about 3/4 of the way out from the Orion spur right here. Okay? If I see this, Milky Way, we're located here, it takes us about 250 million years to rotate around once in this Milky Way, okay? So if our life expectancy is 100 years, that's not much compared to 250 million, is it? So the stars will move very low in your lifetime. They'll move some, fractionally, but not that much, okay? So that's why. That's why the solar system's right on there. It's just the stars. You see this little gray line here? That's called the eclipse.
Okay, could you point to that one
I'm
more
sorry.
time?
You're about to, I forgot about her. I'm about to wear this child out. Let me set this over here.
Oh, this is it.
Oh, thanks for the meteorite. That's what, if any of you keep up with the zodiac, and those constellations, there's 12 of them, they'll fall right on this very, not here called zodiacal constellations. However, there's 88 total constellations, 44 north hemisphere, 44 in the southern hemisphere. But you won't see them all on this. Now, this is north, and guess what's in the north skies? The North Star, right? Polaris. So we're going to look up here, like that light bulb there is the North Star. So what you do, you orient this thing to the north like this, use the compass, okay? If the sun goes down over here in the west, you just spread out your arms parallel to your body, and you point to the west and you're facing north, okay? And that's how you can find it. Or you can go to the Big Dipper, all of you know how to find that. The pointer stars, as you see here, the pointer stars on here point straight to Polaris. It's an easy find. Okay? So anyhow, this is not just that part of the sky right there. This is all of the sky, from horizon to horizon, every bit of it. Okay? From horizon to horizon. So, you see a star over here in the west? Little bitty star over there, behind it. It's right over there on the horizon. You see it straight up in here? It means it's straight overhead. The darker dots are the bigger, lighter stars. So, now, we're going to do a test. Okay? One of you know your birthday. So look up what the night sky is on your birthday. Okay? So Mama, can you help him?
The first one who finds their birthday gets a picture,
Okay, we got.
and they got it correct. Okay? So look for your birthday on there.
I thought you was gonna have a Milky Way candy bar.
Zodiac wasn't.
Yeah, their birthday, when they're, find the day and,
By the day and the month.
May 20th.
no, I have to do, like this.
By the day and the
So the
month.
first one that finds it,
Yeah,
like,
July 6th or something like that.
The PM or the AM.
Well, it depends on when they're.
has anybody found their birthday yet? You
How are we
have?
doing on the birthday?
Can you point it out to me?
It's a very important day because my best friend's birthday is on the 17th. We have it.
Maybe for 9 p.m.
I think we have it.
Let's be with you in a minute. Let's be with you in a minute.
You can pick which one you want.
It's October.
My son took these pictures. These are what are in our skies. That's Jupiter, there's Saturn, that's Andromeda,
Or the stars.
that's Trifid and, it's just Trifid and Lagoon, and that's the Horsehead Nebula, was the Flame Nebula.
This is what the stars try to see. I
So you get the picture of it, whichever one you want.
about this like
They've got, they've got their.
Okay, I'll give one more away.
go see that lady over there.
Let me help take a picture.
Everybody,
Whose birthday was it?
everybody happy?
November 17th.
Okay.
Did everybody that wanted to learn this, have they learned it?
That's and Jupiter. You can have one of these
Everybody
pictures.
learned these, or are you still trying to find your birthday?
May, this is May.
And on the back, it tells you about it. On the back, yeah. That's all I can give away right now. We're giving out little gifts and stuff to. Where's our sun goddess?
Oh wait, mine. Right here. My ticket's inside.
You're the sun goddess? What's your name? Lillian? This is for you?
Thank you. You share it with your sister?
Yes.
Yeah, so you're really interested. You're gonna have to send over Christmas email, aren't you?
Everybody finished with the Star Wars?
Okay.
Thank you for sharing that with us.
Got one more Star Wheel out? Okay,
I'm hanging
you
this
gotta
up
move
right
on.
Yeah.
Sorry.
I don't know where that is.
Thank you.
Near my desk.
Okay, everybody want to have a seat?
What I want to do is
All the Star Wars out? Good. Did anybody learn anything? Parents?
Where are your other two helpers at?
You'll remember enough about it where if you're interested when you get home, the kids are asking questions, you could possibly buy one of those off of Amazon or eBay or something like that, or go to your local store. I don't know, do you have Star Wheels here? You don't? In the library? Oh, you want to get one? Because you've got a solar system up here.
Maybe when the new library comes.
Yes, ma'am.
Okay. Do you have astronomy books?
Yes, I'm sure we do.
Okay.
No, we have books on the planet and stuff, so.
Okay. Any questions? Because I'm going to pass the baton off to, which one, Jack or?
Ben's outside.
He's going to talk to you about the solar system. The planets. There you go. Where's the?
Ben's outside.
It's outside.
Yeah, he's setting up the scopes.
Morning. Mr. Ben is outside setting up a solar telescope. This is a special telescope, and it's the only kind that you should be looking at the sun through unless they have a special sun filter on the scopes. Now, right now, there's not very many storms on the sun.